Okay guys, for this example we're looking at two ropes now. There's two different tensions we're going to be looking for. We have the tension in the rope here. So we're looking for the tension of rope 1 and the tension of rope 2. And this entire body is accelerating downward at 4 meters per second squared. So just like before, we got to break it up, but we're going to actually break it up in two spots so we can try to figure out what the tension inside those ropes are. So we redraw our diagram. So we end up something like this. We have 35 kilograms. If we start at the bottom, we have the force of gravity pointing down, which is just the acceleration due to gravity, which is 9.81 times 35, gives you 343 newtons. Then we have the tension 2 pointing up. So that gives us our first system. Put a little, separate them there. Then our second system has the same tension going down. The force of gravity of the box, which is just 60 kilograms times 9.81, which gives us 588.6 newtons, and the only force pushing up is tension 1. So let's break this up and we'll try to solve for the bottom piece first. So for the bottom piece, we do as we always do. We try to find the net force. We look at the net force in the y direction, because in this case we are accelerating downward at a rate of 4 meters per second squared. Our net force in the y is not going to be 0. Our net force in the y is going to be the mass, which is 35 kilograms, times negative 4 meters per second squared. And that's going to equal the two forces acting in the y. Oh. So 35 times negative 4 meters per second squared will equal the tension minus 343, because the gravity is pointing down. So we calculate this and we get 35 times negative 4 gives us about negative 140. So we have negative 140 newtons is going to equal T2 minus 343.35 newtons. So we add 343.35 to both sides, and we get 203. T2 is going to equal to 203 newtons. We'll just round it there. So we found the tension 2. Now to find the tension 1, we use that value and we make that equal to our 2. So this is also going to be equal to 203 newtons is equal to tension 2. So to find tension 1, we now solve again except for the top half. So we start over. So we say that the net force in the y is going to equal the mass, which is 60 kilograms, because we're going to assume these ropes are weightless, times negative 4 meters per second squared. And that's going to equal all our forces acting in the y, which is a T1 pointing up, minus the T2, which is 203 newtons, minus 588.6 newtons. That's coming from here and here. So we make this, we try to figure this out. So 60 times negative 4 equals negative 240 newtons is equal to T1 minus 203 newtons minus, it's going to equal to negative 791.6. And we add that to both sides and we get 551. So we found both our T1 and our T2. And we're done.